Okay, so I'm going to re-explain this question just to make sure that everyone gets it. A stone was dropped off a cliff, so it's at the top over here, and it hits the ground with the speed of 120 feet per second, and we're looking for the height, which is over here, of the cliff, okay? So essentially we know that our velocity, which is the direction, or sorry, speed in a direction, at the very top when time is zero, and as it plummets to the ground, when it hits the ground, we know that our velocity is at negative 120 because it's going down. So this is just the velocity at whatever time it happens to hit the ground. It's equal to negative 120, okay? So remember, for your gravity, you need to know that A of t is equal to negative 32 feet per second. So this is just something you want to remember. And then from here, we know that if we start with our position function, we take the derivative and we get the velocity and then acceleration. So as we go down, that's our derivative, but as we're going up, that's when we're taking our antiderivative. So if we're starting on acceleration, to go from acceleration to velocity, we need to take the antiderivative. So that would give us vt, okay? So when we take the derivative of just the number, that adds on our variable, and then we need to tack on our constant, okay? So one thing about this constant, it's with respect to our velocity. So to make it easier to understand, I would write this as a variable v with respect to t, okay? So, sorry, so not a variable, well, yeah, it is a letter, but essentially I would just denote that this arbitrary constant is from the velocity equation, okay? So now, from here, we can use this information here where our v naught 0 is equal to 0. So we'll take this right here and we'll plug it in. So we have v of 0 is equal to negative 32, 0 plus v. Now this v naught becomes v of 0 because our t is 0, equal to 0, okay? We have two equal signs, so it doesn't matter if you do this and this, or this and this, or this and this, or this and this, or this and this, right? You just pick two sides of the equal sign. So essentially, I'm going to pick these two on the right-hand side and solve for v naught. So obviously this goes to 0, and we get v naught is equal to 0. Okay? Cool. So essentially, this v of t is going to go to 0. So we have v t is equal to negative 32t, and then we don't have anything. Okay? Now from here, we can take the antiderivative again. So if we go from our velocity, that's going to take us to our position. So when we take our antiderivative, sorry, that's supposed to be s. When we take our antiderivative, we get our position function. This already has a t. I'm going to just write the number and the sign, add the 1, which gives us a 2, and then divide by that number. And now I have to add by my arbitrary constant. So I'm going to write s of t, okay? Now, from here, we can think about other information that was given. We know, we already used the v naught is equal to 0, but we also know, that v of t is equal to negative 120. So I actually skipped that step. So I'm going to go back and do that now. So we can take that and plug it in here, okay? So if I do that off to the side, v of t is now negative 120 equal to negative 32t. So if I solve for t, I divide both sides by negative 32. And I get t is equal to 3.75, and that's going to be seconds because of the units they gave us. Seconds, okay? So now from here, our goal is to figure out when the height of the cliff what is the height of the cliff? So essentially, we're looking for our position when your time is t. Does it make sense? At the top of the cliff, your time is 0. And when it goes to the ground, your time is t. So we're actually looking for st, which we can find right here. So from here, we are going to set our s of t equal to 0. And then we have negative 32t squared. Ooh, I should have simplified. I knew something was weird. Okay, sorry. S of t. So if we simplify that, we get negative 16t squared plus s of t. So essentially we're looking for this s of t. So I move this to the other side. So s of t is equal to positive 16t squared. And we know previously that our t is 3.75. So the position when your time is 3.75 seconds, which is how long it takes for it to hit the ground, we get 225 feet, again because of our units.